Hi guys, this is Mina and I'm excited to introduce you to data models. At the end of this video, you would know what a data model is and the importance of having one. I will introduce you to the stages involved in designing a data model and the different types of data models that exist. We will base our explanations on a case study so you can get a clearer understanding of the whole data modeling concept. So what is a data model? It is a visual representation of database objects such as tables, and it helps us to organize data to be logically stored within a database. With data models, we can easily establish relationships between our tables and also to store accurate and quality data within our database. Lastly, it helps us to enforce business rules, security, and regulatory compliances on our data. So what are the stages of data modeling? The first stage is the conceptual level, where we identify our database objects and the highest level of relationships between the different entities. We do not assign attributes or keys at this stage. Here is a case study to help us understand the conceptual model, and I've provided a copy of this case study below this video in the description section, so feel free to refer to it. In this case study, a company has several stores in multiple cities in a province, and the manager wants us to design a data model to help him track product sales in all the stores. I have two solutions for this case study. In the first solution, one would say that, oh, there is a company. I would have company as an entity, and also there is manager. So I'll list manager as an entity, and then go on to select city, product, store, and sales transaction. However, in your conceptual level, you have to understand that you will be moving on to another stage where you would assign attributes. In this question, we only have a company and one manager. So if we move on to the next stage with this first model, we will not be able to get enough attributes for the company or manager, as there are only one company and manager. The second model will be the right one, because in the question it says multiple cities. So under city we can have several cities, and those are going to be the attribute for the city table, as well as products and store and transactions. This makes the second model the correct solution for this case study under the conceptual level. So this is how our conceptual model should look like. As you can see, we have properly identified all our entities and the highest level of relationship between the entities, which is this arrow, and also we have not specified any attributes yet under this level. This conceptual level diagram is also called the entity relationship model. The second stage of data modeling is the logical level, where we take our conceptual model and specify attributes for each entity. So city entity has attributes, city name and city ID, and also we specify primary and foreign keys. So city ID is the primary key for the city table, and that city ID is listed under store table as a foreign key, so that there will be a relationship between the city table or city entity and the store entity. The store table also has attributes of its own, which are the store ID, and that's a primary key, and also store name is an attribute for the store table. The same applies to product entity and sales transaction entity. We have attributes for product entities and also sales transaction entity. The third and final stage of data modeling is the physical level, where we represent all our entities in a database management system. And here it's a build-up from the logical model, and within the database management system, entities will become tables. So city entity will be created as a table within the database management system. and then every attribute for that particular entity becomes column names. So city ID that was attribute under our logical level will now be column names. We also specify data types. So city ID will have a data type of an integer, and primary and foreign keys will also be indicated for the appropriate columns. Also in the store table, we have store ID as a column name, integer is the data type, and PK as a primary key, and city is being linked to store table. So we have city ID, integer, and it's a foreign key here. We did that for the rest of the tables. Moving on to the types of data models, we have two types of data model. The first one I'm going to talk about is the relational data model that was propagated by Bill Aylmon. This uses the normalization technique. So data normalization is basically organizing data into multiple related tables, and the purpose of that is to reduce data redundancy. So this is the model we generated from the beginning of this video, and it's actually a relational data model. We can achieve relational data model by applying the normal forms. We have the first normal form, second normal form, and third normal form, so on and so forth. Think of normal forms as rules that you need to follow in order to obtain a relational data model. And I intend to teach more about the normal forms in a future video. Once normalization has been applied to our model, we tend to have separate and independent entities which are being linked to each other. For instance, city entity or city table is an independent entity, and it's being linked to the store entity using the primary and foreign key concept. What I mean by separate and independent entities is that each entity or table should contain attributes that pertain to that particular entity. So for instance, in this city entity, it has only attributes that pertain to the city entity, such as city ID, city name. We do not have any other attributes that does not belong to city entity. If we do that, that's going to create data redundancy in our relational data model. Now, foreign keys also ensure that there is referential integrity between tables. What I mean by that is, for instance, if data does not exist in the city table, it cannot be entered into the store table. The database management system would throw an error if we try to do that. If our scenario is changed and the manager now wants us to include product category in our model, for us to obtain a normalized relational data model, we need to create a separate table for product category and link it to the product table. Remember, in relational data model, we are breaking entities down into multiple related tables, and the purpose of that is to minimize data redundancy. Also, if the company now has stores in other provinces, then we need to create province table and link it to its corresponding related table, which is city table. In this case, we have achieved normalized model by instinctively applying the normal forms. However, I intend to show you in a future video what these normal forms are. The second type of data model is the dimensional data model, which was invented by Ralph Kimball. In this model, we denormalize the data by grouping related data together in order to obtain smaller number of tables. And by so doing, we increase performance. Under the dimensional data model, we have to identify what we call dimensions. Dimensions are descriptive entities. So, for instance, store is a descriptive entity, and also product. All the attributes for products are descriptive, and city. So these are called dimensions. And then we have to identify what we call fact. Facts are the metrics or numeric measurements, such as sales amount and quantity sold. Once we identify the dimensions and facts, we have to create the fact table. So the fact table will contain the facts, which are the metrics, and also foreign keys of all the associated dimensions. This diagram is often referred to as a star schema because we have a fact table in the center surrounded by multiple dimensions. If the manager now wants us to include product category in our modeling, unlike the relational data model where we will create a separate table for product category, here we can merge product category name into the product table and have the same table for both product and product category. So as you can see here under the product table, I have product category and product name. Also, if the company extends to other provinces, instead of creating a separate table for province, we can easily change our city table to location table and include our province name under the same table. So under dimensional model, we are grouping like data into the same table in order to obtain minimal tables, and we are making sure that we are separating our dimensions from our facts and linking them together to obtain a star schema. So this brings us to the end of our introduction to data models. Thank you so much for watching this video, and feel free to refer to my other YouTube videos on dimensional modeling. Have a great day.